So, this class I will solve a few example problems related to earth pressure theory, and then I will show how you can calculate the forces that is acting on a wall or the retaining structure due to this. This is the backfill. Okay, so, first problem that I have chosen, that I have two soil layer. Okay. So, two soil layer, one is the thickness H 1, another thickness is H 2. So, one soil layer this is K A 1, one soil layer this is K A 2. Okay. So, this is the K A 1 is the coefficient of active earth pressure for layer 1, and K 2 is the coefficient of active earth pressure for layer 2. Okay. Now, I have chosen three cases. The case 1, that if your K A 1 is equal to K A 2, then what will happen? Case 2, if K A 1 is less than K A 2 or K A 2 is greater than K A 1. Okay. And case 3, where your K A 1 is greater than K A 2 or K A 2 is less than K A 1. Okay. So, these three cases, and I will draw only the earth pressure. Okay. So, draw the active earth pressure. So, for the first case, this is the first case. So, I will draw the first case earth pressure, this is for the first layer, and this value is gamma. So, here you can say the both the cases gamma are same, and I have not considered the water table effect also. So, I can write this is gamma, or you can write this is gamma 1, this is gamma 2 also. So, if this is gamma 1 H 1 into K A 1. So, this is this value. Now, this first layer soil overburden pressure or stress will act as a surcharge on the second layer. Okay. So, first layer overburden pressure will act as a surcharge on the second layer. Okay. And surcharge with Q is equal to gamma 1 into H 1. So, that Q will act for the second layer. Okay. So, that, and as I mentioned for the surcharge, this will be Q into K. Now, here the K is equal to K 2. So, this value will again remain same. The surcharge value will remain same, because this is your gamma 1 H 1 into K A 1, because your K as K 1 is equal to K A 2. That is why I can write that. Okay. Now, this is the surcharge for the first layer. Now, the second layer earth pressure will be again this one. Okay. So, this part is second layer earth pressure, and that will be gamma 2 H 2 K A 2, or gamma 2 H 2 K A 1 also you can write, because, or you can write gamma 2 H 2 K A 1. Okay. Because you have the K A 1 is equal to K A 2. But in the second case, this is for the layer 1. Okay. So, layer 1 as usual the same thing, I will draw the same thing, that is gamma 1 H 1 K 1. Okay. Now, your K A 1 K A 2 is greater than K 1. Now, again Q value is gamma 1 H 2. Now, this will not remain same. So, that is very important. When you calculate the earth pressure in a layered soil, if you have different Ka value, then you have to check for the intersection of every layer, one for the first top layer, one for the bottom layer, the same point. Okay. So, that means gamma 1 H 1 K 1 is for the earth pressure at this point corresponding to first layer. Now, corresponding to second layer, because that will act as a surcharge gamma 1 H 1. Now, it is into Ka 2 and Ka 2 is greater than Ka 1. So, your earth pressure will increase, you will go this direction. So, this is very important. Okay. So, now this value is nothing but gamma 1 H 1 into Ka 2. Okay, that is why I have chosen this problem, so that I can show you that what would be the difference. So, now this is for the UDL part. Now, for the second layer earth pressure will act. So, this is for the second layer earth pressure, that will be gamma 2 H 2 Ka 2. Okay. And this one is gamma 1 H 1 Ka 2. This is very important. Na? And another one is case 3, that we are taking the same problem and up to this first layer there will not be any issue. Okay. And this value as usual, this value will be gamma 1 H 1 Ka 1. Now, your Ka 1 is greater than Ka 2 or Ka 2 is less than Ka 1. So, this value will decrease. Okay. And then you have this UDL part, and this value is gamma 1 H 1 Ka 2. Now, your Ka 2 is less than Ka 1. So, that is why it will decrease. Then from here this force or the stress will act, and that is gamma 2 H 2 Ka 2. So, these three figures are very important. Remember these three cases, that if in the changing of K value, so you cannot always draw this stressed diagram. Okay. If it can be this one also, it can be this one also, it can be this one also. And I will show later on how I will calculate the forces and the point of application, but this is the earth pressure diagram for these three cases. Okay. So, next example problem that I will take, that this is again the example problem, that we have a earth pressure draw the earth pressure for this type of soil. This is a sand and it is in dry condition. Okay. So, now here GS is given 2.65, E is given 0.7 and phi is given 32 degree. So, what is the difference? In previous problems also, in the previous problems I have given directly the unit weight of the soil, but sometimes you will find that directly unit weight of the soil may not be given. It is given in terms of, this is the specific gravity, G is the specific gravity, E is the void ratio, in terms of void ratio. So, you have to determine the unit weight either dry or saturated or bulk depending upon the values given. Okay. So, now here it is a dry soil. So, you know the unit weight of dry soil is G 1 plus E gamma W. Okay. This is the dry unit weight expression. So, these 2.65, this is 1.7, gamma W if I take 1. So, this will be 15.6 kilonewton per meter cube. Okay. And we have a Ka value is equal to 1 minus sin phi and 1 plus sin phi. So, this will be 1 minus sin 32 degree and this will be 1 plus sin 32 degree. So, Ka value is 0.31. So, my distribution of the earth pressure will be, because this is the homogeneous soil. So, distribution of the earth pressure will be like this, and this value is equal to this is gamma, your H value is 10 meter, this is the H is 10 meter. So, gamma into H into K A. Okay. And so, your this value is gamma is 15.6 into H is 10 into K is 0.31. And if I draw the final force P A, so this P A is equal to half into gamma into K A into H square. So, this is half into gamma is 15.6 into K A is 0.31 into 10 square. Okay. So, this will be 241.8 kilonewton per meter square. This is the case 1. Okay. Now, in the case 2, I have taken the same soil layer, but the water table is at 3 meter below the ground level. Okay. So, this is the ground level GL, this is the wall, here also this is the ground level. This is 3 meter and this one is 7 meter. The same problem I have taken. So, this is the gamma dye, but this is gamma saturated. Okay. But same G value, E values are given. So, I have to calculate it the gamma sat, which is equal to G plus S is 1. So, E plus E into gamma W. Okay. So, G value is 2.65, E value is 0.7 and 1 plus 0.7 into 10. So, this is 19.71 kilonewton per meter cube. So, this is the gamma sat, and gamma dry we know that 15.6 kilonewton per meter cube. Okay. And here one thing, that your P A is acting H by 3. So, that is 10 by 3, that is 0.33 meter from the base of the wall. Now, in this case, if the water table is considered, now is this case up to the water table? We can draw this earth pressure, and this value is nothing but 15.6, this is gamma dry, into the H is 3 into the Ka is 0.31. Okay. Because your phi value will remain same, whether it is dry soil and it is saturated soil. Here given in this way, phi value, Gs value, E value will remain same. So, this is the 30.31. So, this value is 14.51 kilonewton per meter square. Okay. Now, as the phi value is not changing, so your Ka here and Ka here will also remain same. So, this is also remain same, it will not change. Okay. So, that means here this is the 15 into 6 into 3 is the surcharge, and K will remain same. So, it will continue okay, here. So, this value will also be 14.51. Okay. This is kilonewton per meter square. Now, I will calculate the stress for the soil, and that stress is here, this one is, this is the gamma is, in that case this stress or P A, I can write that here P A S for the soil, I can write here that gamma is here, saturated is 19.71. So, this will be the sub okay, into 10 into H is 7 meter into Ka is 0.31. So, this will be 21.1 kilonewton per meter square. So, this value is 21.1 kilonewton per meter square. So, this stresses is for the soil. Now, for the water will also give you the stress. So, this is the water stress and this value is nothing but 7 into 10, okay, because water we will not multiply any earth pressure coefficient factor, because for the water this factor value or coefficient is will not multiply, will multiply it only for the soil. So, this third part is will be 70 kilonewton per meter square. Okay. So, finally, we have this expression where this is 14.51, this is 21.1 and this is 70. 70 is due to the water, 21.1 and 14.51 is due to the soil. Okay. So, now this is the earth pressure distribution if we have a water. Okay. Now, here the Pa is acting at H by 3, but here where the Pa is acting. So, that we have to calculate. We have to calculate that if your Pa is acting here, okay, and say that is a height of y bar, okay, height of y bar. So, now how I will calculate y bar? Y bar is, so it has 4 parts. Okay. This is the part 1, this is part 2, this is part 3 and this is part 4. So, I am taking all the forces. So, first I will calculate the force Pa, then I will calculate the y bar. Okay. So, first I will calculate the force and then I will calculate the y bar. So, okay, I am using another table. So, quickly I am drawing that another sheet and quickly I am drawing those values. So, this is the values is 14.51 kilonewton per meter square and this is 3 meter, then that will continue and this is also 14.51 kilonewton per meter square. Then there will be a triangular zone whose this is 21.1 kilonewton per meter square. Then this water part, that value is 70 kilonewton per meter square and this height is 7 meter. So, I am calculating the Pa which is acting at a height of y bar from the base of the wall. So, now the Pa is, so I have 4 parts 1, 2, 3 and 4. So, first part I am talking, it is a triangle. Okay. So, this triangle, this will be half into 14.51 into the H 3. Okay. This is for the first part. For the second part, it is the rectangle. So, this will be 14.51 into 7. Okay. Then it is a triangle, third part is a triangle. So, this will be the half into 21.1 into 7. Okay. And then we have another triangle. So, then it will be again plus half into 70 into 7. So, these are the all forces that we have considered. Okay. So, now if I take these two, this is for the first case, for the second one, this is for the third one and this is for the fourth one. So, 1, 2, 3 is due to the soil, fourth one is due to the water. Okay. So, and finally, if I calculate this one, this first one is given 21.77, second one is given 101.6 and the third one and fourth one is given 318.9. This is the second one, first one, second one, this is third plus fourth. Okay. Why I have taken third plus fourth? Because third plus fourth you can consider as a whole triangle, base is 21.1 plus 70, 21 plus 1 plus 70 and then both cases it is 7 and a half. So, that is why I have taken as the same 3 and 4. Okay. So, that is the finally the P A value is 442.2 kilonewton per meter. Okay. This is kilonewton per meter. Remember that this is kilonewton per meter, because in the plane strain condition. So, again now y bar I will calculate now for the these 4 cases. Okay. So, first the y bar for the first case, your force is 21.77. The lever arm I am calculating from the base. So, lever arm will be 7 plus it will act 1/3 from this base, because it is a triangle, first one 1/3 from the base. So, this is 3 divided by 3. Okay. This is for the first one. The second one, the force is 101.6 and it is a rectangle, it will act at the middle. So, it will be 7 divided by 2. Okay. And then I am taking third and fourth one as one triangle, and the force is 318.9 and it will act as 1/3 from the base. Okay. So, it will act 1/3 from the base. So, it will be 7 divided by 3, because it is a one triangle I am considering, third and fourth I am considering as a one triangle. So, it will act 1/3 from the base. So, 7 by 3 and divided by the total force 44.2. This is the total force P A. Okay. This one is nothing but as a P A. So, finally, the y bar will be 2.88 meter. So, y bar will be 2.88 meter. So, if I see this problem here, y bar was 3.33 meter. Now, due to the and the force was sorry, this is P A. So, this P A is kilonewton per meter, correct that. This is kilonewton per meter, because this is force, and small p is the stress, kilonewton per meter square, but the capital P is the force, it will be kilonewton per meter. Okay. Just correct that. And here it was 241.8, now it is 442.2, and this is the point of application of this force is 2.88 from the base. Okay. So, that is the change. So, that is why when you design the retaining wall, you always avoid this water. Okay. We will make such arrangement, that means we can avoid this water, because water will increase the force in significant amount, you can see that. So, now the next problem that I will solve, that is case 3. Okay. So, in the case 3, I will consider one surcharge. Okay. For the surcharge, I am talking the same problem with water, the same problem, I am taking the same problem 7 meter and this is 3 meter, but with a surcharge 50 kilonewton meter square. Okay. And the rest of the things are same. Okay. So, now for this total problem, so you know the surcharge P A is K A into Q. So, and here K is not changing. So, suppose if we have a soil where K value is different for 2 layer, this is first layer, this is second layer, then for the surcharge your K value will be maybe something like that, depending upon the type of K. If this is K1, this is K2. Now, if Ka1 is less than Ka2, then this will be the distribution. Okay. But here if the Ka1 is equal to Ka2, then this will be the distribution. Okay. And if Ka1 is greater than Ka2, then this will be the distribution. Okay. So, but our case it is K1 is greater than K2, Kn1 is equal to K2, because K is not changing. So, I can write a uniform surcharge that will act throughout this depth. So, and that value will be equal to 50 into 0.31. Okay. So, 50 into 0.31, that is 15.5 kilonewton per meter square. Now, for the next one, this is for the first layer that I have already calculated. This is 14.51 kilonewton per meter square. That 14.51 will continue in this layer. So, this is also 14.51 kilonewton per meter square. Then for this soil and this then for the water. So, for the soil and for the water. So, for the water this will be 70 kilonewton per meter square, and for the soil this will be again 21.1 kilonewton per meter square. So, this except this 15.5, all the other stresses I have already calculated this problem. This is 14.51, this is 21.2, this is 70, except this additional force or this due to the surcharge is added additional stress. So, finally, the PA value also we can calculate from here. So, now instead of 4 there are 5 components. So, PA value will be here, and if I take this is one triangle. So, then this will be 4 components. Okay. So, now PA value will be, this is for the rectangle, this will be 15.5 into 10, okay, plus this first circle first triangle half into 14.51 into 3. Then the next one, this rectangle, this is, so this is first, second, third, and together this one it is 4. Okay. So, this is for the first case, first one, this is for the second one, and for the third one it is 14.51 into 7. This is the rectangle for the third one, and for the fourth one again half into 14.51 plus 70 into 7. This is for the fourth one. Okay. Half into this one 21. This is for the 14 into 3 half, this is 14 into 7, okay, and this one we have added, this is 21.1 plus 70 into 7, 21, and the final value is 597.2 kilonewton per meter. Okay. So, this is the case 3 when we have considered a surcharge, and then we can calculate what would be the stress or what would be the force PA acting on the wall. Okay. So, next problem that I will consider, next example problem, where I am considering for the C5 soil. Okay. Till now I have solved one particular homogeneous layer with a phi soil. Now, I will consider a C5 soil, and we have to consider or we have to calculate what is the active earth pressure or PA. So, now all these things I am considered active. Okay. This is also active case. So, the problem is that we have a wall with 2 different layer. This is a 2 meter layer, and this is 8 meter thickness. Okay. Here it is phi value is 20 degree, C value is 20 kilonewton per meter square, and we have a unit weight is 17 kilonewton per meter cube for the first layer, and second layer unit weight is 18 kilonewton per meter cube, phi value is 30 degree and C value is 0. Water table effect is not considered. This is the ground level, which is far below. Okay. So, first one we have two different layer, this is layer 1, this is layer 2 and two different phi. So, we will calculate K 1 is 1 minus sin phi divided by 1 plus sin phi. So, this is equal to 1 minus sin phi is 20 degree and 1 plus sin 20 degree. So, that is equal to 0.49 and K A 2 is also 1 minus sin 30 degree 1 plus sin 30 degree. So, this is equal to 0.33. This is K A 2 is 0.33, this is K A 1 is 0.49. Okay. So, now we have the P A expression for the C phi soil is gamma Z K A minus 2 C root K A for the active case. Now, this is the expression. So, first layer the P A at Z equal to 0. So, that will be this is 0 minus 2 C value is 20 and root 0.49. Okay. So, that value is minus 28 kilonewton per meter square. Okay. So, minus 28 kilonewton per meter square. Now, we can calculate what is the Z0 value. Z0 value is this expression of Z0 is 2 C divided by gamma root K A. This is the Z0 expression. So, 2 into 20 divided by gamma is 17 and root 0.49. Okay. So, that Z0 value is coming to 3.36 meter. So, and but the first layer is 2 meter. Okay. So, Z0 will not cross this layer. Okay. So, Z0 will not cross this layer. So, now let me draw the calculate the other stresses also. Now, the P A at Z equal to 2 meter for the first layer. Okay. For the first layer, as I mentioned that if we have two different layers, we have to calculate the stress for a intersection of or interface of these two layers for the first layer as well as the second layer. So, Z equal to 2 for the first layer, it will be gamma is 17, Z is 2, K is 0.49 minus 2 into 20 minus 0.49. Okay. So, this is equal to minus 11.34 kilonewton per meter square, because it is why it is also still minus, because your Z0 value is 3.36 and your thickness of this layer is 2 meter. So, this layer totally will be the under the minus negative stress. Okay. If this layer thickness is greater than the Z0 value, then there will be a positive stress, otherwise it will be negative stress. Now, the P A Z equal to 2 meter for second layer will be, now second layer is only phi soil. Okay. So, the first layer stress will act as a surcharge and first layer stress is gamma into 2 meter gamma 1 and that will be K A 2 into K A 2 and this is the surcharge coming from the first layer. Okay. So, the gamma value is 17 into 2 into K A 2 is 0.33. Okay. So, now if I draw this diagram, that this is the 2 meter minus 2 meter, this is minus 10 meter and 0. So, here This is the diagram for the first layer. So, this value is 28 kilonewton per meter square, and this one is 11.34 kilonewton per meter square. This is for the first layer 2 meter, okay, and this is total negative. Now, for the second layer, it is the sandy soil, and for the second layer this is K A2 into the surcharge coming from the first layer, and surcharge coming from the first layer is gamma into 2 meter. This is gamma into 2 meter. So, this value is 11.22 kilonewton per meter square, and remember that will be positive stress, because it is only phi soil. So, that will be the positive stress and it will go this direction, okay, and that will continue up to this point. Okay. So, this one is 11.22 kilonewton per meter square. Now, P A at z equal to 10 meter, okay, that means at the end of this oval or the base of the oval. So, that at 10 meter this 11.22 will remain there. Then the additional one, that because of this second layer, the additional one I am calculating. So, this is the same as this rectangle. So, additional one will be this gamma 2 H 2 or the H 2 into K A 2, because it is phi soil. So, this will be 11.22 plus gamma is 18, H 2 is 8 and K A 2 is 0.33. Okay. So, this is 11.22 plus 47.52. So, the total one is 58.74 kilonewton per meter square. So, this one is 47.52 kilonewton per meter square. Okay. So, because this is for the rectangle, this is for the triangle. So, this is 11.22 is already there. So, the total one, this one is 58.74. Okay. So, you can calculate in this way. So, finally, the P A value, I am calculating here. So, as I mentioned, when you calculate the P A value, we will not consider the negative one. So, I will consider only the positive one. This is 1 and the second one. So, now as I mentioned that here also, if it is mentioned that you draw the earth pressure before the tension crack is developed, then this will be the earth pressure. Okay. And then if you consider the you have to calculate the force, then you have to consider the negative one. And if you have to, this is the before the tension crack. Now, the after the tension crack is developed, so this will be your earth pressure diagram. Okay. This is the earth pressure diagram. This is after okay. This is after and this is before. So, after this will be the 2 meter and this value is 11.22 and this one is 47.52. This is after, this is before, and we are calculating the force after the tension crack is developed. So, I am calculating for this one. So, I am calculating this is the P A. Okay. Generally, we do not consider this one, but if it is specifically mentioned that you determine the force before the tension crack is developed, then you have to consider the negative one also, but here we will not consider, because we consider only the positive one. Okay. So, positive one Pa will be, this is the 11.22 into the 8 meter height for the rectangle, then the triangle half into 8 meter into 47.52. So, this will be 279.8 kilonewton per meter. Okay. And similarly, you can calculate what will be the Pa acting, that means y bar also you can calculate, as I have already shown in the previous examples. So, you can calculate the point of applications also from the base. One is considering rectangle, another is considering triangle. In triangle it is h by 3, for the rectangle it is h by 2. Then you can calculate the y bar. So, in the next class I will also solve few more problems considering more number of layers, phi as well as C phi soil, and then I will show you how to calculate the lateral earth pressure in those cases. Thank you.